Hello everyone. In this video, we review for final. So this is the first part of a final review for MAT 102 Intermediate Algebra. You will have a 50, 50 multiple choice questions. So today we try to cover 25 of them. Let's get started. Number 1. Solve the equation. The equation is a linear equation in one variable. 8x minus 15 equals 4x plus 9. How many terms in the equation? 2 on the left, 2 on the right. So in total, we have 4 terms. And allow me to color them different. So we have a blue term and a yellow term. On the right-hand side, we have a green term and a pink term. In order to solve the equation for x, we need to isolate x on the left. In order to isolate x on the left, we need to have the variable terms together on the left first. So we're going to apply the transposition of terms, the technique we have learned, to collect like terms. Obviously, the blue and the green are like terms, right? We want to collect them on the left. So I copy 8x. We copy 8x and move 4x over. The green term, we move it over. Remember, you move a term from one side to the other side. You move it and you change the sign. You move it and you change the sign. And on the right-hand side, you have a 9, the pink term. And you want to move negative 15 over because the yellow term is a constant. Yellow and pink are like terms, right? So you move negative 15 over, you have a positive 15. Transposition of terms is a very useful technique. We can apply the technique to collect like terms in the equation very efficiently. Now the like terms are collected. On the left-hand side, we have 8x minus 4x. On the right-hand side, we have 9 plus 15. We are ready to combine like terms. How do we combine 8x minus 4x? When we combine like terms, we're combining their coefficients, right? So I don't mind to spend time to explain 8x minus 4x. 8x is like you have 1, 2, 3, 4, 5, 6, 7, 8. You have 8x. And now you remove 4 of those. So how many x left? 4, yeah. That's how do we have 8x minus 4x, right? Yeah. 8 minus 4 is 4. 4x on the left. On the right-hand side, what is 9 plus 15? 24. Very good. One more step to isolate x on the left. Right now, the coefficient of x is 4. We want the coefficient of x be 1. In order to do that, we divide both sides of the equation by the coefficient 4. Because 4 over 4 gives 1. That's how do we isolate x. So now we have 1 times x. X equals, on the right-hand side, 24 divided by 4, we have 6, right? So the answer will be the solution set of the equation is a set containing one solution, which is 6. Any questions? You can pause the video and watch that part again. This is number 1, solving linear equation in one variable. We applied the transposition of terms technique. Let's look at number 2. Number 2, solve the inequality and write the solution set in interval notation. The inequality is negative 3x bigger than or equal to 18. Let's see this inequality. One term on the left, one term on the right is a simple inequality. The inequality symbol is no less than or bigger than or equal to. Solving inequality is very similar with solving an equation. Remember when we cover this part, we had a paragraph states the only difference between solving an equation and solving an inequality is when you multiply or divide each side of an inequality by a negative number, you have to reverse the direction of the inequality symbol. Do you have that impression? Yeah. So here we want to solve for x. So we need to isolate x on the left. In order to isolate x on the left, we need to get rid of the coefficient -3. In order to get rid of the coefficient -3, we want to divide the left-hand side by -3. So we have to do the same thing on the right-hand side. So right-hand side also divided by -3. So if we divide each side of this inequality by -3, do we need to do something? Do we need to do something to the inequality symbol? It is bigger than or equal to. Is there anything important we need to do here? Yeah, flip the sign or flip the direction of the inequality symbol. It's going to be less than or equal to. Very, very important. That actually is the purpose of number 2. Yeah, because we divide each side of this inequality by -3, negative number. So we have to switch the direction of the inequality symbol. All right, then on the left, -3 over -3 gives us 1. X is isolated. Less than or equal to on the right-hand side, what is 18 divided by -3? Positive divided by negative, we have a negative, right? Yeah, very good. So x less than or equal to -6. This tells us the solution set of the original inequality include all the real numbers no more than -6. No more than -6. Does that include -6 itself? Yes, right? Yeah. So let's graph the solution. Let's graph the solution set on a real number line. Let's say -6 is right here. All the real numbers less than or equal to, so all the real numbers to the left of -6 also include -6 itself. So we have a bracket. We have a bracket here. All the numbers, all the points covered by the interval in red are in the solutions. Look at the graph. Remember, we define an interval as one single piece on the real number line. That is one single piece. Look at the piece. What's the left and the point? What's the left and the point of the piece? They are that direction. Left and the point. Hello? What's the left and the point? Forever, forever, forever. So what is that? Negative infinity. Very good. Negative infinity. What's the right end point? -6. Very good. So this is how do we frame the two endpoints. Always use parentheses to frame infinity. At the right endpoint -6, we use bracket because -6 is included, right? So that's how do we handle number 2. Solve the inequality. Very important. When do we need to reverse the direction of the inequality symbol in the inequality? Also, how do we rewrite the result in the interval notation? Question about number 2? If not, let's see number 3. Number 3, we need to solve an inequality. -5x minus 7 is bigger than negative 6x minus 10. How many terms in the inequality? How many terms in the inequality? 4, 2 on the left, 2 on the right. So allow me to color them. Blue, yellow, pink, green. 2 terms on the left, 2 terms on the right. So we're gonna collect like terms first and then combine them. We're gonna collect the blue and the pink together because they are like terms, obviously, right? In order to do that, we apply the transposition of terms. We copy negative 5x. We move negative 6x over. Negative becomes positive. We copy bigger than. On the right-hand side, we're gonna put the yellow and the green together. We copy the green and move negative 7 over. We have a positive 7. So look at it here. Blue and pink together. On the right-hand side, we have green and yellow together, right? What technique we applied here? Transposition of terms. Yeah, very useful, very efficient. On the left, the two like terms are together now. We are ready to combine them. Negative 5x plus 6x. Negative 5 is the coefficient of the blue. 6 is the coefficient of the pink. We combine like terms by combining their coefficients. What is the negative 5 plus 6? 1. So we have a 1x on the left, right? Very good. We have a 1x on the left. On the right-hand side, what is the negative 10 plus 7? Very good, negative 3. So once the left-hand side, once x is isolated on the left, then the solution part, the solving part is done. The rest of the work is to graph the solution set and write the solution set in an interval notation. Real number line. Let's say negative 3 is right here. All the real numbers, how do we understand or interpret the solution? The solution set of the inequality is a set containing all the real numbers bigger than negative 3. So graphically speaking, all the points to the right of negative 3, all the points to the right of negative 3, but excluding negative 3 itself. So that's why we have a parenthesis, left-hand parenthesis at negative 3. Okay, look at the one whole piece in red. What's the left end point? Where does the piece stop on the left? Negative 3, right? Yeah. And what's the right end point? Positive infinity. Very good. Yeah. Left end point, right end point, and we use a comma to separate them. For the left end point, we have a parenthesis because negative 3 is excluded. Yeah, because this is strictly bigger than. On the right, at the right end point, infinity, we use a parenthesis again. So the result is a negative 3 to positive infinity. So from A, B, C, D, you're going to choose this one as a correct answer. Questions? Any questions? Let's see number 4. Name the quadrant, if any, in which the point is located. The point is negative 18, 16. Point is defined as an ordered number pair. A point in a rectangular coordinate system is defined as an ordered number pair. The first component is the x-coordinate. The second component is the y-coordinate. D-I-N-A-T-E, coordinate. If the x-coordinate is positive, that means the point is to the right of the origin. If it's a negative, it means the point is to the left of the origin. For the y-coordinate, if it's a positive, means the point is above the origin. If the y-coordinate is negative, then the point is below the origin. Yeah, so with that, we have this point, negative 18, comma 16. So the point represented by the ordered number pair is to the left and above the origin, right? Above the origin, left above. So this is the rectangular coordinate system. We have a 4 quadrant, right? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. This is the origin. So which quadrant is to the left and above the origin? Yeah, so you're gonna choose quadrant 2. All right, is that doable? Yeah, we can look at the graph here in my notes. In quadrant 1, right top, both x and y are positive. In quadrant 2, left top, x coordinate is negative, y coordinate is positive. You see, I always go very detailed because we are using those stuffs. Quadrant 3, left bottom, both x and y are negative. Quadrant 4, right bottom, x is positive, y is negative. So with this diagram, I believe you can handle the problem for number 4. Okay, any questions? If not, let's see number 5. Number 5, we need to complete the table for the equation. The given equation is y equals negative x plus 4. And let me copy the table here. It's a 2-column table. Column 1 are values for x. We have a positive 2, negative 4, and 0. So we need to fill in a blank. We need to get a number here, here, and here. Yeah, that's the task for number 5. When you look at the equation that is given, what do you think? Yeah, that's plug in, but graphically. So what's the graph of the equation y equals negative x plus 4? Slope-intercept form of a straight line. Yeah, so that's a straight line, right? Yeah, very good, straight line. So what we're gonna do is we're gonna find the y values for the corresponding x value. We're gonna find the corresponding y value for the given x value. Yeah, you are right, we just plug in. Let me label those as 1, 2, 3. So in order to find the value of y corresponds to x equals 2, we just plug in. So number 1, we plug in x equals 2. Yeah, let's copy the equation y equals negative x plus 4. Plug in x. So we copy negative, copy plus, copy 4. We do not copy x. Instead, we're gonna put 2 in the place of x. That is called a plug-in, right? All right. Then what is the negative 2 plus 4? Negative 2 plus 4. Very good. Perfect. So the corresponding y for given x equals 2 is just 2, right? Is that doable? Very straightforward. Yeah, we learned this chapter 2, I think. Chapter 1 or chapter 2. Number 2, same thing. We're gonna plug in x equals negative 4. Yeah, just be careful when you deal with those signs. Y equals negative x plus 4. We copy negative. We use x. We use parentheses to hold the place for x. We copy plus 4, and then we put x equals negative 4. We put a negative 4 in the parentheses. And what is the negative negative 4? Negative negative 4. Negative negative. So how do you understand? What? Is a positive 4, right? Yeah. So how do you understand this this expression? That's the opposite of negative 4. Yeah, exactly. It's just a positive 4. Yeah. You change your way to think, to understand the notation, then you will see the answer. It's the opposite of a negative 4. The opposite of negative 4 is a positive 4. What is the 4 plus 4? 8. Yeah, so the second value here is 8. It's gonna take a little bit of effort, but I think it's straightforward, still straightforward. Number 3, we're gonna plug in x equals 0. The equation is y equals negative x plus 4. We plug in x equals 0. Negative 0 is still 0, right? So 0 plus 4 is 4. So the third value in the table is 4. So the answer you're going to choose supposed to look like this. Okay, 2 colon 8 colon 4. Yeah, that's how you that's the answer you should choose for this problem. Yeah, because 2 is right here, 8 is here, 4 is here, right? Yeah. Any question about number 5? Any question about number 5? Let's move to number 6. Find the x and y intercepts, then graph the equation. Let me copy the equation. It is 3x minus 12y equals 12. Yeah. When you see this equation, you should know, okay, that's a straight line, right? Yeah, that is a straight line. So if we have a straight line, for example, this one, a slant straight line, let's say, the intersection of the line with the x-axis is called the x-intercept. Yeah, we are reviewing for the definition of x-intercept and the y-intercept. The intersection of the straight line and the y-axis is the y-intercept. All right, so that means x-intercept is on the x-axis. So the y value of x-intercept must be 0. Same thing. Y-intercept is on the y-axis. The x value of y-intercept is 0. Okay, so how do we find the x-intercept and the y-intercept? This is the process. So we are going to find, how about let's find the x-intercept first. So we're gonna make y be 0. Okay, we're gonna make y be 0. So 3x and solve for x. 3x minus 12 times 0 equals 12. 3x, 12 times 0 is 0, right? So the term is just 0, equals 12. Yeah, let's write this closer. 3x equals 12. Divide both sides by 3. By 3, we have x equals 4. So you see, as y is 0, x is 4. Yeah, as y is 0, x is 4. So x value go first always, follow with y value. 4, 0 is the x-intercept. Okay, 4, 0 is the x-intercept. Let's see, how do we find the y-intercept? Y-intercept is on the y-axis, so the x value is 0. So we're going to make x be 0 and solve for y. We have 3x minus 12y equals 12. So we make x be 0. So 3 times 0 minus 12y equals 12. What is 3 times 0? 0, right? So we have negative 12y equals 12. Coefficient of y is negative 12. In order to isolate y, solve for y, we divide both sides by negative 12, and y is isolated on the left. On the right-hand side, we have 12 over negative 12. What is 12 over negative 12? 1. Positive divided by negative is negative 1, right? Everybody, yeah, negative 1. Very good. So you see, as x is 0, y is negative 1. Yeah, that is a pair. That is a pair. So 0, negative 1 is the y-intercept. Is the y-intercept. That's the standard process for finding x-intercept and y-intercept. Once we have x-intercept and y-intercept, we can graph them. So x-intercept 4, 0. So we have, so the point is right here, 4, 0, the orange point. Yeah, 4 units to the right of the origin on the x-axis. And the y-intercept is 0, -1. So from the origin, go down 1 unit. Go down 1 unit. This is the y-intercept. So you draw a straight line passing through the 2 points. One is x-intercept, the other is y-intercept. You will have the graph of the line. All right? So any question? Okay. If not, let's move to number 7. Number 7 is to find the slope of the line. You will be given a graph of a straight line. You need to identify the slope for the straight line. We know slope is rise over run, right? Yeah. So if you can, how about let's see this way. Do you see this blue point? Do you see this black point? Let's see, this is A, this is B. So suppose you go from A to B. Yeah, you go from A to B. What is your rise and what is your run? You go from A to B, so you go up, right? So your rise is a positive. How many units go above? 2 units above, right? Yeah. And from A to B, you are going to the right, to the right direction. So that's positive. Yeah. How many units do you go from A to B horizontally? 3, exactly. So here you go. So if you are given a line in graph, finding the slope could be just a thing to find the rise and the run. Just a matter of finding rise and run graphically. Yeah, rise and run. Is that clear? You see the slope is positive, and that is consistent with the fact that the graph is going up. If the straight line going up, slope is positive, right? Yeah, if the line going down, then the slope is supposed to be negative. Any question about number 7? We plan to cover 25 in 15 minutes, right? Right now it's almost 30 minutes. Number 8, decide whether the relation is a function. Relation is a set of ordered pairs. This is a relation. However, this relation is not a function. Why? Because look at those 2 pairs. They have the same x, different y. Correct? Yeah, in order to be a function, for each x, you could only have 1 y. But this relation, for x equals 1, you have 2 different y's. That disqualifies the relation to be a function. It's not a function, okay? It's not a function. It's not a function. Does that make sense? Number 9, decide whether the relation a function and give the domain and the range. Look at the graph. The graph is a straight line. You see the 2 arrowheads means the line extending to both directions indefinitely. Do you guys remember we have a technique is called vertical line test, right? Yeah. So apply a vertical line test and tell me, is this graph a function or not? Yes. And what's the domain and the range? Try to understand the domain is all real, the range is all real as well for a straight line. Okay? Because horizontally, the line is extending to both directions indefinitely. Vertically is the same thing. So all the real numbers, yeah. Domains are real, range is all real as well. Number 10, graph the linear inequality in 2 variables. Well, this is a long process. We're gonna try to just talk about the most important thing, two-step procedure. So this problem has a two-step procedure. The first step is to graph the boundary. How do we find a boundary? We change the inequality symbol to equal sign. We got x plus y equals 10. This is the boundary line. Okay? You're gonna graph the boundary line. In the graph, the orange dashed line is the boundary x plus y equals 10. The reason we graph it as a dashed is because the inequality symbol in the original inequality is strictly less than, right? It does not have the equality in it. So we draw the boundary dashed. That is step one. Step two, we find a testing point. Normally we use 0, 0. Yeah, as long as 0, 0 is not on the boundary, we always use that because it's convenient. So you're gonna plug in 0, 0 here to the original inequality and tell me, do you have a true statement or contradiction? 0 plus 0 less than 10 is a true statement or contradiction? You plug in, yeah, true statement, yeah. So that means you're gonna shade the region. You're gonna shade the region below the boundary, including the origin. So you're gonna shade the region below the boundary. Yeah, all the points below the boundary, all the points in that half plane, those are the solutions. All right. So we don't have time to go very deeper. Yeah, we learned this before. We are not learning this. We are reviewing. Number 11, if the ordered pair 5, 2 belongs to function g, then g blank equals blank. Yeah. So how do we understand that? Remember, function is a machine. Function is a machine, right? You give the machine an input, the machine will produce a unique output for you. So the fact that 5, 2 belongs to the function means the x value is 5, the y value is 2, right? That means if you give the function, sorry, the function is g in this problem, it's g. It's just a notation. Means if you give the function g x equals 5, the function g will produce y equals 2, right? So you're gonna put the input here, output here. Does that sound familiar? Does that sound familiar? So those problems, you have seen them in the tests already. Yeah, they might be the same problems, maybe a little bit different. Okay, so am I clear about number 11? Yeah, you just need to know this guy is the input and this guy is the output. Okay, x value is the input, y value is the output, and that's enough. Number 12, very simple. Y to the power of 4th times y to the power of 2nd times y to the power of 5. Product rule. When you multiply powers with like bases, you keep the base, you add the exponents. What is 4 plus 2 plus 5? 11. Here you go. It's easy, right? Number 13 is also simple. X to the power of 10 over x to the power of 4. When you divide the two powers with like bases, you keep the base and subtract the exponents. Always use the exponent in the numerator minus the exponent in the denominator. What is 10 minus 4? 6, yeah. So the result is x to the power 6, okay? Yeah, again, in the final, whatever the formula you need, I'll give you. So focus on understanding the application of the formulas. Number 14, very straightforward. X to the power of 2 and then to the power of 4. Remember the name of the formula. is called a power rule, right? Yeah. So you keep the base, and how do you deal with the two exponents? Multiply. Awesome, very good. 2 times 4, 8. So the result is x to the power 8. Question? Very straightforward, right? Number 15 is also straightforward. 2 over 7 to the power 2. The structure of the expression is a power of quotient. Remember, power of quotient is a quotient of powers. Power of quotient is a quotient of powers. What is 2 square? What is 7 square? And here we go. Yeah, those supposed to be still fresh, right? Yeah. Power of quotient equals quotient of powers. And then you evaluate the numerator and the denominator. You have the result. Number 16. Number 16. The expression is -5x to the power of 3. Look at the structure of the expression. Yeah, what's the structure of the expression? It's a power of product. Power of product is a product of powers. You see in the base, the base is a product. Blue times green. Blue times green to the power of 3 is the same with blue to the power of 3 times green to the power of 3, right? Okay. Tell me please, what is the cube of -5? Cube of -5. -5 times -5 times -5. What is that? Negative 125, right? Yeah. And then multiply by x cubed. Here you go. That's the answer you're supposed to choose. All right? A, B, C, D. Number 17, straightforward, just the formulas. 8 to the power of -2. How do you get rid of a negative exponent? You get rid of the negative exponent, change it to positive. So you have 8 to the power of 2, but you put that in the denominator. Use 1 to over the denominator. Yeah, straightforward application of this formula, okay? Yeah, x to the power of n, x to the power of -n equals 1 over x to the power of n. I think they are very, very easy. Number 18. If we have a non-zero quantity, and the non-zero quantity is raised to the power of 0, what's the value of the power? Here, that's the formula. You see, you need to focus on understanding the formula. You don't have to make too much effort to remember it, but you need to understand it. This means if the base is non-zero, the zero power of the base equals 1. So do you understand? Do you see the result supposed to be 1? Yeah? Yes or no? Yes. Okay, very good. Thank you for your response. That's number 18. Number 19, subtracting polynomials. Subtracting polynomials is pretty easy. So let's just take a little bit time to process this. -7x cubed plus 10x squared plus 4 minus inside the parentheses -5x cubed. How about this? Do you guys want to use the vertical method or horizontal method? I have both of the solutions in the notes. And which one do you prefer? Vertical. Okay, let's do vertical. So for the vertical, you're going to put the first polynomial on the top. The polynomial inside the parentheses, that's the second. You're going to put right below the first. So -5x cubed plus 2x minus 5. Yeah, you need to be careful with the structure. That's the first. The second polynomial is inside the parentheses. Okay, so make sure the like terms are lined up, are aligned. So you can see they are not aligned yet, right? Yeah. So you have 0x plus 4. And this one, the second one missing x squared terms. So be very careful if one term is missing. You have to make it up. So did you guys see that? So you the first polynomial missing 0 times x, missing x term. The second polynomial missing x squared term. So you have to make them up in order to make the like terms are line up. All right, so now we are ready to do the vertical. Minusing a number is equivalent to adding the opposite. So we copy the first polynomial and then reverse the signs in the second polynomial. So we have a -5, we're gonna write that as a +5. We have a +0, we can write that as -0x squared. -2x becomes +2x. -5 becomes +5. And let's add them up. Let's add them up vertically. What is a -7 plus 5? -2 or +2? Yeah, -2x cubed. And a 10 minus 0, just 10. 0 plus 2, just 2. 4 plus 5, 9. So that's the final result. Okay? So if you choose to use the vertical method, did I write something wrong? Oh, okay, sorry, my bad. So here is a positive 2x. -5x cubed plus 2x. So here it's going to be negative. So here we would have a negative. Yeah, so don't rush. Sometimes I want to rush and let me double check. All right, that's correct. Yeah. So if you apply the vertical method to minusing to take the subtraction of two polynomials, make sure you have those like terms aligned. Number 20, find the product. The product is a monomial times a binomial. 3x squared is a monomial. Inside the parentheses, we have a binomial. We're going to use the formula for distributive property. A times B plus C equals A times B plus A times C, right? Yeah. So this is how do we do that. We're going to use 3x squared to times 5x plus 3x squared times -6, all right? 3x squared times 5x, what is 3 times 5? 15. What is x squared times x? X cubed, awesome. What is 3 times -6? Perfect, times x squared, right? Yeah, so here we go. That's how do you multiply a monomial by a binomial. Number 21, find the GCF for 5 and 15. The whole semester, I cannot remember how many times we talk about GCF, LCM, special case number 1, special case number 2. So please know that what is special case number 1, what is special case number 2. So when you look at 5 and 15, 5 is a factor of 15. 15 is a multiple of 5. Is that special case number 1 or special case number 2? Yeah, thank you. Special case number 1. So in special case number 1, the GCF is the smaller number. LCM is the bigger number. All right? So number 21, GCF of 5 and 15 is the smaller number 5. LCM of the two numbers is 15. Okay, special case number 1. So let's do one similar problem. Let's say 12 and 144. Look at the 12 and 144. What's the GCF of the two numbers? Yeah, what's the LCM of two numbers? Perfect. So that's it, right? 2 points for this. For special case number 1, you got 2 points for that. And number 23 and number 24, you're going to find the GCF and the LCM for 4 and 21. 4 and 21. 4 and 21. If you prime factor the two numbers, 4 is 2 times 2. 21 is 3 times 7. Look at the two numbers. Do they have any common factor except 1? No. We call those two numbers what? How do we call the two numbers? If the two numbers have no common factor except 1. Mutually prime. Mutually prime, okay? Yeah, mutually prime, exactly. Mutually prime. That's the special case number 2, right? Special case number 2 is mutually prime. Yeah. So if the two numbers are mutually prime, GCF is 1. LCM is their product. Do you guys remember that? GCF is 1 because they are mutually prime. So 1 is the only common factor. That makes 1 the biggest common factor. So GCF, greatest common factor, is 1. LCM, in order to find the least common multiple, we have to use all the factors in the factorization. So that basically is the multiplication of the two numbers. So multiply the two numbers. In order to see if you really understand that, try 4 and 7. Tell me please, what's the GCF of 4 and 7? Huh? Yeah, perfect. They are mutually prime, right? Yeah. What's the LCM of 4 and 7? Perfect, 28. Multiply them together, right? 4 times 7, 28. Yeah, so another 2 points. Easy, easy, all right? Yeah, number 25. Number 25, you need to find the GCF and LCM for 30 and 36. Not a special case number 1, not a special case number 2. It's a regular case. We did this the first class of this semester. I have a 3-step procedure for that. First step is to prime factor both numbers. 30 is even, so divisible by 2. Divided 30 by 2, we have 15. 15 is divisible by 3, right? Divided 15 by 3, we have 5. So 30 equals 2 times 3 times 5. Same thing with 36. Divided by 2, 18. Divided by 2, 9. Divided by 3, we have 3. So 36, Dennis, you mentioned the technique last time, right? So that's the technique, big L technique, yeah. So you stop the process when you see a prime number on the bottom, yeah. So 36 equals 2 times 2 times 3 times 3. For GCF, you bubble, I use red, bubble the common factors. Your GCF will be the multiplication of the common factors. In this case, is 2 times 3. What is that? 6. That's GCF. For LCM, you're going to do more. Besides the red bubbles, you're going to have green bubbles. Bubble the leftover factors in the 2 factorization. So for LCM, you're going to copy all the factors in the bubbles. But when it comes to common factors, you only write once. So you see the red bubble, you only copy the ones. You do have 2 2s. You have 2 3s, but you only copy them once. And then copy the numbers in the green bubbles. 5, 2, 3. They are in the green bubbles. And multiply them all together, what do you have? The number is 180, okay? So make sure you know GCF stands for greatest common factor. So it's a smaller number. When you look for GCF, you are looking for a smaller number. LCM, even the first word is least, but you are looking for a bigger number. The number has to be common, has to be a common multiple for both. All right, so that is number 26. So we're gonna stop here and continue next Monday. You guys know when do we have the final, right? Look at the Moodle announcements. Yeah, the time for final of so let's see. Yeah, look at the announcement here. Yeah, Friday. Yeah, in a week. Thank you guys for coming. I'll see you next time.